Today's lesson is 5.6, Part B, Writing Linear Inequalities. So in order to write a linear inequality, the first thing we need to do is we need to be able to identify the slope and the y-intercept. So if we look at this first graph, we want to identify the y-intercept, or where it crosses the y-axis. And you will see this graph crosses the y-axis at 0, -2. So our y-intercept is 0, -2. We also need to know our slope. So we do have to find another ordered pair on our line. So we could see that it crosses right there at -2, 2. You could also use -1, 0. Whatever two ordered pairs you choose. And remember to do or to find our slope, we always want to count our rise over our run. So when we're finding our slope, we're counting our rise over run. How do we move up and down compared to how we move left and right? So if I start with my y-intercept, I would have to go up 1, 2, 3, 4 units. So my change in y would be a +4. But then I would have to go left 2, so my change in x would be a -2. And then we would simplify 4 divided by -2 is -2. So I have a slope of -2. Even if you chose to start at the other ordered pair, so even if you chose to start at -2, 2, for that specific one, your change in y, you would have to go down 4, which would be a -4. But then you would have to go right 2, so your run or your change in x is a +2. And so you would still end up with a slope of -2. So either way, your slope is -2. Now, I'm going to go ahead and write this as y, and I'm going to leave a space because we have to know what inequality symbol to put in there, but we do know that our slope is -2, so it's -2x, and our y-intercept is -2, so it's -2. Remember, we're looking at y equals mx plus b, where m is our slope and b is our y-intercept. So now I just have to decide which inequality symbol I need to put in the box. So the first thing I notice is I use a solid line. So I know it has to be equal to. So I'm going to put a solid line underneath or where I'm going to put my inequality symbol because it is equal to. So what I would suggest you do is pick any point that is in the shaded region. I'm going to choose 0, 0. Because 0, 0 is in the shaded region, and so this ordered pair should make our inequality true. So if I substitute in a 0 for y and a 0 for x, this should make the inequality true. So I have 0 minus 2 is -2, so I have to ask myself, is 0 greater than or equal to -2, or is 0 less than or equal to -2? And it is greater than. So I know that my symbol between the y and my -2x minus 2 would have to be greater than or equal to, because that's what would make it true. So let's try another one. Letter B. Letter B, we see that our y-intercept, again, is -2. So that would be 0, -2. And then we need another ordered pair on our line. So I'm going to choose our x-intercept. And we're going to count our slope, which is rise over run. So on this specific one, if I start at my y-intercept, my change in y, or my rise, is a positive 2. I go up 2. And then I have to go right 2. So my change in x is also a positive 2. And 2 divided by 2 is a positive 1. So my slope is 1. So we have y, and I'm going to leave a space for my inequality symbol, but I have 1x minus 2. Now, you will never see the 1 written, so I'm going to erase that. So you will only always see it written as just x minus 2. Now, I do know that I'm not going to put the equal to symbol because this is a dashed line, so it's either going to be greater than or less than. I'm going to choose an ordered pair that is in my shaded region, and so I'm going to choose 0, 0 is not in my shaded region, so I'm going to choose a different one. I'm just going to choose 4, 0. So 4, 0 is my test point. 4, 0 should make my inequality true. So my y value is 0. My x value is 4. 4 minus 2 is 2. So I have to ask myself, is 0 less than 2 or is 0 greater than 2? Well, 0 is definitely less than 2. So I'm going to replace my box with a less than symbol. That makes it true. That test point makes it true. So notice when our equations are in slope-intercept form, our first one said y is greater than or equal to, greater than implying that we shaded above the line. So if you have your equations in slope-intercept form, if it says greater than, then we are shading above the line. Notice in equation B, when it says y is less than x minus 2, if we are in slope-intercept form and it's a less than, we shade below. So in this case, below would be to the right. It just depends on what type of slope you have as to where above and below that line is. So that's why I always recommend choosing a test point in the shaded region, and then you put the inequality symbol in to make it true. And then last but not least, we have our 2 special cases. So remember, unless you are Spider-Man, you cannot walk up a wall. And so if we look at a vertical line, our vertical line has an undefined slope. It is undefined. Likewise, if we look, it does not cross the y-axis. We do not have a y-intercept. So if we do not have a slope and we do not have a y-intercept, our inequality is not going to be written in slope-intercept form. That means it's always going to be x instead of a y. And in this case, if we look at our line, every single x value of every single point is negative 2. This is negative 2, 0. This is negative 2, 2. This is negative 2, 4. Negative 2, 6. Every single x value is negative 2. So that means we're going to have x, and then we either are going to have greater than or less than. So I'm going to leave that box alone for now. And I'm going to ask, is it equal to or not equal to? And it is, because it's a solid line, so we know we're going to have a line underneath. And then I'm going to choose a test point. Good thing for us, 0, 0 is in our shaded region. So 0, 0 should make our inequality true. So my x value is 0. I don't have to worry about substituting in y. And I just have to ask, is 0 greater than or equal to negative 2 or less than or equal to negative 2? And 0 is definitely greater than or equal to negative 2. And so I'm going to replace my yellow box with a greater than or equal to -2, because that's what makes it true. And notice it's a greater than or equal to -2, so I shaded all numbers to the right of our vertical line because those are numbers that are greater than or equal to -2. So I'm shading above, so to speak, that vertical line. Then if we look at D, letter D is a flat horizontal line. And so if we recall, a flat horizontal line has a slope of 0. If you forget, you can always choose 2 points. You can ask yourself for your slope, what is my rise? Do I have to go up or down to get to my next ordered pair? And you do not. Your rise is 0, but you do run in between these 2 points 1, 2, 3 units to the right, and 0 divided by 3 is 0. So your slope is 0. You do have a y-intercept. It crosses your y-axis at 5, so that's 0, 5. Which means we can write the inequality y, and then we're going to leave a space for our inequality, 0x plus 5. Remember, it's y equals mx plus b. Our m is 0. Our slope is 0, our y-intercept is 5. Now, 0 times x is 0, so technically if we have 0 x's, you will never see the 0x written. So we're actually just going to write this as a y, and then with the 5. Now you have to ask yourself, do I have to use the equal to, or is it a dashed line? And we do need the equal to symbol, so it goes underneath. And then I have to choose an ordered pair in my shaded region. So I'm going to choose 0, 6. That means I'm going to substitute 0 in for x and 6 in for y. Well, I don't have an x, so I'm just going to choose to put 6 in for y. And I ask myself, is 6 greater than or equal to 5 or less than or equal to 5? It is definitely greater than or equal to 5, so I'm going to replace that green box with a greater than or equal to. And notice that that makes sense because I shaded above. Numbers that are greater than or equal to 5 would be above 5. And so I would shade above. And that's how we write inequalities.